So let's ask a different question when it comes to relations. So what if we want to describe all of the elements that are related to a given element? So instead of me telling you this element is related to this, or I give you a rule that says all of these elements are related to this other one, let's ask the question, given a relation, what are all of the other elements that something is related to? So we have this definition. So we're going to say let A and B be non-empty sets and let R be a relation from A to B. So remember, these elements in A, those are going to be entries of our first thing from our ordered pair, and elements from B will be in the second part of our ordered pair. So for each element X that's in A, the relation class of X with respect to this relation is defined by the following. This R with square brackets of X is now the set of all of the elements in the second part here, all the elements in B that X is related to. So X is related to Y for all of these. Now, many cases, we will just understand the relation in context, or I will give that relation to you. So we'll often just write the square brackets around a given element to define what all of the things that this is related to, what that would be under this relation. Okay, so to look at these relation classes, let's take a look at this example. So this first example, we're going to define this relation of saying that A is related to B if A is less than B. So we'd like to describe this as a relation on all of the real numbers. So we're asking the question for this, what are all of the real numbers that are related to 2? So we're trying to figure out, in this case, 2 is our first entry. What are all of the elements that 2 is going to be less than? Well, if we're on R, that means it's going to be an infinite number. There's going to be a whole bunch of these, and it's going to be all of the numbers larger than 2. So we can define that as the set of 2 to infinity. So what you have over here is that you had 2 is less than, say, B, defines this set here. So we have the interval 2 to infinity, because we were looking at all of these elements B, what set is defined by this property. Same thing here now, 3, what are all of the elements that 3 is related to? So all the real numbers that satisfy 3 is less than that, well again, that's going to be 3 to infinity. So then for any number that I give you, the relation class here is very simple to define, right? For any number, the relation is given by all the numbers that are larger than it, so all of those will be simply x to infinity. And again, this is true if I give you any real number. This is our relation. So each of these are our relation classes. So this next one, now we'd like to take a look at this other example that we looked at before. As a reminder, we said that this is an equivalence relation. This was reflexive, it was symmetric, and it was transitive. So again, keep that word in the back of your brain. That is an equivalence relation. Okay, so if we define this on all of the integers, so we're trying to figure out what are all of the numbers that 1 is related to. So in this case, again, 1, these are always going to be this first element. This x is an element of A. So we're saying that 1, what are all of the B values that make this true? So this is again a set. This is the set containing 1 and negative 1. 1 is related to 1, 1 is related to negative 1, and that's it. Those are the only possible choices. 0, we see, okay, what numbers is 0 related to? Well, in this case, it's only the set containing 0. Because we have negative 0 is the same thing as positive 0. Now if we look at this, so if we have this other relation of A is related to B if A divides B. So again, remember the order of what am I saying is related to it. I'm not saying what numbers are going to divide 1. I'm saying what numbers does 1 divide. So 1 divides what? Well, again, if you're thinking about divides, remember what we're saying by this definition is we're saying that there exists some k in the integers such that we have A times k is equal to B. So many of you have gotten hung up on thinking about this as division and saying, well, when I divide something, it's one of those weird things where, yes, our brain goes to division, but this statement is a statement about multiplying numbers. So do not start dividing things. Only write these as saying a times an integer is equal to something else. Okay, so 1. 1 times what is going to be equal to what? Okay, so this case, every single number is going to work for us. Every integer will have the property that 1 divides it. So the set for this is simply the set of all integers. Now 0, what numbers does 0 divide? So 0 divides what? So again, we're thinking that these are going to be this a in this case. So if we look at this, we're going to have 0 times some k is equal to b. So k is allowed to be any integer. So what is this allowed to be then? What is b? Well, 0. That's the only thing. So 0 divides 0. And that's why I say, don't think about this as actual division, because 0 divided by 0 is undefined, right? We know that from a computation standpoint, 0 divided by 0 is undefined. However, the statement 0 divides 0, we have not restricted that. It's just a simple statement about multiplication. So, indeed, this is containing 0. And then 2. Now we're trying to figure out how would we define the numbers that 2 divides? Well, that would be something like 2, right? 2 divides 2. 2 divides 4. 2 divides 6. 2 divides negative 8. 2 divides negative 2. So this is going to be all even numbers. So this is the set of all even numbers. Now, there's lots of different ways that you could write that. You could write it in set builder notation that we learned a while ago. You could just simply write it like this. The important part is that you're able to recognize what this set consists of, and this is all even numbers.